My name is Weizman Dudai and I am from the Department of Neurobiology at the Weizman Institute of Science, Rehovot, Israel.
And I'm Uri Nili. I'm also from the Department of Neurobiology at the Weizman Institute of Science.
And here is Nachshon. Nachshon means a small snake in Hebrew. And Nachshon is a collaborator in our study. We are very grateful to Nachshon for inducing intense fear in the participants of our study. Over the next several minutes, we will guide you through our study entitled Fear Thou Not, Activity of Frontal and Temporal Circuits in Moments of Real-Life Courage, which we have conducted together with our colleagues Hagar Goldberg and Abraham Weizman. In this study, we asked, how does the brain encode courage in a real-life fearful situation that demands immediate response? To act courageously is to perform a voluntary action that is different from that promoted by ongoing fear. It is noteworthy that courage as here conceived focuses on action in spite of fearfulness that is observed in the general population rather than on an exceptional trait, fearlessness. Hence, it is of great interest to us all. Our premise was that by gauging properly defined actions of either overcoming fear or succumbing to it in an acute, controllable fearful situation, one can render brain substrate of courage amenable to investigation in lab setting. But how can this be achieved?
We devised a paradigm that enables induction of a sustained realistic ambience of fear within the fMRI scanner, while giving participants the opportunity to choose between overcoming or succumbing to the ongoing fear. We also measured the behavioral expression of these choices. We selected a snake as a fear-eliciting stimulus since fear of snakes, often intense, is common in the general population. Specifically, a live, rather big snake, or a toy bear, a control stimulus intended to evoke no fear, were secured to the top of a trolley that could travel stepwise on a conveyor belt, spanning the distance between the far end of the scan room and close proximity to the back of the participant's head within the scanner. The participant's task was to reach maximal proximity to the snake while overcoming the fear they might experience. In each trial, while their brain was being scanned, the participants were prompted to choose, by pressing a response button, whether to advance the snake one step closer or move it further away. During scanning, the reported fear rating and skin conductance response for each decision were recorded as well. Two groups of volunteers took part in the study, selected to permit multiple intra- and intergroup analysis of behavioral performance, physiological reaction, and brain activity. Fearful, composed of healthy individuals who fear snakes, and selected by using a validated snake fear questionnaire, and fearless, composed of individuals accustomed to handling snakes. The reported fear of participants in the fearful group increased with proximity to the snake, and accordingly necessitated an increase in the postulated mental effort to bring the snake closer. Within a subgroup of the fearful, crossing a certain threshold of fear was associated with a failure to overcome fear, expressed as intermittent decisions to move the snake away. We focused on identification of those brain circuits that differentiate between moving the snake away and bringing it closer. We found that activity in only two brain regions, the subgenual anterior cingulate cortex and the right temporal pole, was positively correlated with choosing to overcome the fear. Furthermore, activity in the subgenual anterior cingulate cortex correlated positively with the level of reported fear when choosing to overcome the fear. In contrast, activity in a set of temporal lobe structures, including bilateral amygdala, was attenuated as the level of reported fear increased when choosing to overcome fear and advancing the snake closer to the head. This pattern was reversed when participants failed to overcome their fear. In these instances, the aforementioned regions exhibited a relative increase in activity, whereas the subgenual anterior cingulate cortex displayed a sharp decrease in activity. All in all, in our paper, we combine our results with current knowledge of fear mechanisms and emotional regulation to propose a detailed model of brain mechanisms that make it possible for us to overcome fear in a real-life fearful situation that demands immediate response. This model posits a set of functional interactions between specific frontal areas, particularly the subgenual anterior cingulate cortex, and temporal circuits including the amygdala.
We hence propose how an internally reinforced fast representational shift in which the courageous response gains control of a behavior takes place. On top of what it tells us about ourselves, our study also has potential applied importance. Particularly, it could contribute to better understanding of what goes wrong when fear comes to control behavior excessively, For example, in an anxiety disorders and phobias.